Okay, electron configuration. Let's do the ones we did on orbital notation. Let's do those first. Here's helium. Helium would just be 1s. Its electrons are in the 1s, and there are 2 of them. Okay, remember this is kind of a summary. We're not representing every single electron with this. Okay, neon, again, the 1s has 2 electrons in it. Drop down, the 2s has 2 electrons in it, and the 2p has 3 electrons in it. Okay, we'll do nickel. We did that one on the orbital. Okay, and look, notice that it always starts the same. The pattern is exactly the same for all the elements because they fill from lowest energy out. So 2p6 puts us right there. Okay, we're still not, nickel's right here, so we still got to keep going. 3s2, 3p6, 4s2, and then 3d8 to finish it up. Okay, if you remember earlier on, we did mention about the fact that completely full or exactly half full sublevels are more energetically favorable, and so that sometimes there's a little bit of variation in the way that they feel, so because it can get a more favorable energy state if it kind of promotes an electron up to achieve either a completely full D sublevel or an exactly half filled D sublevel. Okay, and so we'll look at, here's copper, and it gives this configuration here. Now, all right, let's take a look at this right here. Okay, looks a little different, doesn't it? Well, let's go to, I think I've got a blank one here. Let's go right here. All right. If we were going to do the copper in the normal way we would expect, okay, we would go just like this. 3s2, let's see, copper's right there. 3s2, 3p6, 4s1, 3d10. Okay, it promoted one of the 4 s's up, all right, and then got a full D sublevel that way. All right, now, this is a full or complete electron configuration, the way I just wrote this. There is a way that you can kind of abbreviate. Remember how I said the pattern is always the same. So if I go for copper, if I go backwards to the nearest noble gas, right there is argon. Okay, if I were to do the electron configuration for argon, it would look like this. Okay, this piece of copper, of the copper configuration that I did before. I can take and write argon in brackets, and that is the same as writing 1s2, 2s2, 2p6, 3s2, 3p6. So an alternate way of writing the electron configuration for copper in this case would be argon in brackets, and then we just pick it up where we left off, 3d10. Okay? This is called noble gas shorthand. Okay? And it's just an abbreviated way to write electron configurations. For this class, you may use either form. You may write the full notation, or you can abbreviate it with the noble gas shorthand, unless if you're working on a worksheet and it specifically asks for one or the other, then you need to do it whichever way that they ask. But on a test or a quiz, if I don't specify, I just say for you to write the electron configuration, then you may use noble gas shorthand. Okay, let's do another one. Let's do one that's down here in the F's. Okay, one thing I will tell you about the F's is that There are some exceptions to the way that these fill, but for this class, we're pretty much going to kind of keep things as straightforward as possible. When you advance your studies of chemistry, then you can get into why there's the different exceptions and all that, but for this one, we're just going to focus in on kind of filling lowest energy to high out to the highest, especially with regard to the F's. So let's say we wanted to do europium. All right, and I'm going to do this with the noble gas shorthand because obviously europium is right there, element 63. Okay, and again, remember the way the periodic table works. If you come across our 6th row here, right there after lanthanum, it drops down, goes through here, and then comes back up. And you can see, look at the atomic numbers, and you'll see how they flow there. Okay, so that little piece right there actually should be inserted between lanthanum and hafnium. All right, so europium, if we go backwards to the nearest noble gas for europium, it's going to be, you can read that, xenon. All right, so I'm going to put xenon in brackets. All right, now I'm going to come forward, and I have 6s2. Now, if you are working on an element that's going to stop in that F block, the thing to remember is you've got to include that 1D that's there. And again, we're not dealing with exceptions and promoting things and all that with this F block. I just want you to recall or remember that in the electron configuration for europium, I have to have 63 electrons. And so if I leave that D electron out, it's not going to add up right. So if I'm going to stop in the F block, then I'm going to include 5D1 and then 4F. And europium is 1, 2, 3, 4, 5, 6 into there. Okay? All right, what about one, let's say, how about if we did gold? One where we go completely through that F block. How are we going to deal with that? Well, all right, we go back. We still have xenon as the noble gas we hit when we go backwards. Okay, we're still going to have 6s2. Now, if you're going all the way through the F block, then just go ahead and put them right here. Okay, 4f14. And then we're just going to lump that first D electron before it drops down to the rare earth metals. We're going to lump that one in with the other ones. And so I would come back up, and I'm going to do 5D, and gold is 1, 2, 3, 4, 5, 6, 7, 8, 9. 5D, 9. Okay? I think this should get you enough in there to get some practice. All right? One of the things I'm going to be looking for in your vodcast notes, so that I know that you watched this vodcast, is I would like for you to include, and let's change that. I forgot that I asked for nickel here. Let me pick a different element. How about for arsenic? Okay. All right. So do the orbital notation for arsenic and the electron configuration for uranium. And you may either do the full electron configuration or noble gas shorthand for that.